Alright, here we go. Welcome to Chapter 6. This is Mr. Brust. We're going to kind of continue off Mr. Sullivan's Unit 5 there. We're talking imaginary numbers now. So I know it's kind of a blast from the past. Foster's Home of Imaginary Friends. Classic. I love it. Let's get rolling. Talk about some imaginary things besides imaginary friends and whatnot. Let's take a look at what is an imaginary number, So what's going on here? Well, let's take a look at some things we know here. Square root of 36, got it. No problem. That is just 6. 6 times 6 is 36, so we're okay on that. That's good to go. So those are real numbers. What happens is, in the past you type this in your calculator, the square root of negative 25 doesn't exist. It says non-real answer. It's true, these are not real answers, but we have imaginary answers. So these are called imaginary numbers. What number times itself is negative 25? Well, we know it's not 5 times 5 because that's positive. It's not negative 5 times negative 5 because that would be a positive 25. So what do we say? It's actually 5i times 5i. So the square root of negative 25 is 5i. So these are imaginary numbers. They're not real numbers, but sometimes they're useful to find these things. So they're called imaginary numbers. They were actually, the Greeks knew about these, and they actually made fun of the first couple of mathematicians. Like, hey, look at your imaginary numbers. So it actually started as a joke, finally caught on, and so it really stuck as I. So we're going to use 5i to represent the square root of negative numbers. Fantastic. Try negative 50. So what's the square root of negative 50? Well, this is a little challenging. There isn't a number that goes into negative 50. So really, what does this break down into? This breaks down into I square root 50. So if I times this by itself, the I times the I, that's really what's getting us here. If I look back at this one, 5 times 5 is 25. What is I times I? Well, I times I is I squared. And in this case, we want that to be negative 5. So really, here's the magic of it all. I squared is negative 1. That's what gives us this whole idea of 25 times negative 1 is that negative 25. So if I'm going to skip ahead to my chart here, I squared is negative 1. That's really the key to imaginary numbers. This one right here, this I squared. Awesome. Very nice. So this is great. Can I reduce that? Sure. We're pretty good at reducing these radicals. We've been practicing here for a little bit. So what does 50 break down into? It breaks down into 25 times 2. And why did I pick 25? Because what's the square root of 25? It is 5. So really, this turns into I5 radical 2. We don't write it like that. We always put the number first. So this is actually 5i radical 2. So we're going to spend some time simplifying these things. The square root of negative 50 is actually 5i radical 2. Awesome. Very good. So we're going to practice a bunch of those. Let's go ahead and fill in this table, though, if we're talking about imaginary numbers here. I is just I. So I squared is the key. This is where the magic happens. I squared, as we showed up here, is negative 1. That's what gives us this ability to take the square root of negative numbers. So what's I cubed? I mean, I cubed is really I squared times I. So what happens here? If I squared is negative 1, I is I. What is I cubed? It's actually negative I. Cool. So what is I to the fourth? Well, a couple of different ways of looking at this. You can look at it is, the way I like to think about it is I squared times I squared is I to the fourth. And if you have I squared times I squared, that's negative 1 times negative 1. You're back at positive 1. So this is the key. This is kind of like the key to imaginary numbers. If I look at I to the fifth, essentially I to the fifth is really I to the fourth times I. That gives you I to the fifth. Remember, you add those exponents, it's like to the first. So when I say that, I'm saying 1 times I. I'm back at I. So it's really just a pattern. So what is 6? 6 is actually back to 2. So it's really this cyclic pattern here where it keeps going in groups of 4. Excellent. So if you want to continue the pattern to 15, you could. You go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This would be 15 right here. What's another way to do that? Well, the way I like to think about it is 15. How many times does 4 go into 15? That's how I think about it. 15 goes into 4, what, 3 times? Gives you 12. And the key to this, what's the remainder? It's a remainder of 3. So if you look at that remainder, that gives you the same power. It's I cubed. This is the same thing as saying I cubed because it goes in there 4 times remainder 3, which really equals negative I. So we're actually going to look at these, break these down. What about I-34 then? I-34 is, how many times does 4 go into 34? Should go in there, what, 8 times? But we're really only concerned that cycle happens 8 times. What's the remainder? it's a remainder of 2. So if it's a remainder of 2, that's like saying I squared, which we know is as negative 1. So we're going to reduce these things down. If you get a remainder of 0, it's like saying 4. It goes in there evenly, so it would be I to the 4th. Awesome, very cool. So that's the basic foundations to I. When I think about imaginary numbers, I like to think about, we did the Foster's Imaginary Friends there. Here are a couple of imaginary things I like to think of, imaginary characters. Let's take a look at these. These are my top 3 favorite imaginary things out there. Alright, number 1, the Abominable Snowman. Check it out. I love that. That's pretty awesome. What's my second favorite imaginary character?
Top of the morning to you, laddie.
Kelly Khan. I like that one. And what wraps it up, the third imaginary creature. These are fake. They don't exist, I don't think. The last one, it's not Sasquatch, it's Sully Squatch. I love it. So which of these is my favorite? Gotta be the Abominable Snowman. He's definitely the most imaginary. Haven't seen a video, Mr. Bean, Algebra 2, haven't seen a video from this guy. I'm starting to wonder if this guy exists. He may be purely imaginary algebra teacher. We'll find out more later. Let's solve some of these. So we got these imaginary things. Let's spend some time solving these. So let's take a look at the first equation here. So when we solve these things, same thing. Let's get n by itself here. So we're going to solve for n squared. Mr. Sullivan did this back in chapter 5. These cancel. We're looking at n squared equals what? That is negative 9. And to finish this bad boy off, what do we got to do? We got to take the square root of both sides. So we're going to square root of both sides. There it is. So this used to be the part where you type in your calculator and say, ooh, yeah, that's an error, non-real solutions. Now we're going to get those non-real solutions. So what is the square root of negative 9? Well, the square root of 9 is 3, but it's negative, so it's going to be I. Now check this out. Because we introduced this square root, I put that in there, you have to say it's plus or minus. So before, when the square root was already there in the last slide, you just put the positive version. But as soon as you introduce it to the equation, it becomes plus or minus. So it could be a plus 3i or a negative 3i is going to give you that right there. So we have 2 solutions. Awesome, very cool. How about this next one over here, above Leopard Kellycon here? If I subtract 1 from both sides, boom, we get x squared equals negative 7. And same thing here, so I'm going to introduce a square root. So as soon as I do that, I know it's plus or minus. Plus or minus what? Well, in this case, it's plus or minus I radical 7. So I knew, that was really radical 9i, but I knew the square root of 9 is 3. Do I know the square root of 7? I don't. So that's just how I'm going to leave it. That is the correct answer. Some people will try to say, oh yeah, it's plus or minus radical 7i. We don't put the I back here because it's confusing. It's hard to tell. Is it under the square root or not? It's confusing, so we put that I in front. So anytime, please put that I in front so we know exactly what we're talking about. We know where it is. Awesome. Let's wrap it up with the last one then. So we'll start this thing off by adding 2 to both sides. So we're looking at what? Negative 54. And on the left side, we're left with this 3y squared. So continue to get that y by itself. So we're going to divide both sides by 3. Divided by 3. So finally, we're left with y squared equal. So 3 goes into 54, what, 18 times? Yeah, so divided, we get that negative 18 here. So we finally got y squared by itself. So what are we going to do? We're going to square root both sides. So when we do that, remember, what happens here? We're going to introduce this plus or minus. We've got plus or minus, and then how do we do this? It's got to be imaginary. It is imaginary square root of 18. Excellent. Alright, so let's go ahead and break that down. What is the square root of 18 equal to? It's the square root of 9 times the square root of 2. And does that simplify again? Sure does. Why did I pick the square root of 9? Because I know square root of 9 is 3, so we're really looking at plus or minus 3i square root 2. So if I multiplied that by itself, boom, it would get me back to that negative 18 up there. But that is the final answer. Plug that in, and you should be good to go. Excellent. Moving on. Awesome. Moving on. So we talked imaginary numbers. Let's talk complex numbers. What are complex numbers? Well, this is the general form, a plus bi. And if you see the I, this b is going to represent what? The imaginary part of a complex number. So we've got this imaginary part of a complex number. Over here, what is this a going to be? It's actually going to be the real part. So a complex number is part real, part imaginary. That's why I like to think I can get this unicorn over here. If you think about the horse, part of a unicorn is real, right? That is the real part of this thing. But when I start looking at the horn and the wings, what is that all about? Well, that's imaginary. I don't think unicorns really exist. So that's the imaginary part. So a unicorn is complex. It's part real, horse is real, part imaginary. The wings and the horn just they're not really there. So complex numbers are going to look something like this: 4 plus 3i. So I've got the real part, boom, no problem. That's real. Then I've got this imaginary part with the I, and I can't add them. They're not like terms. They're completely different. One is imaginary, one is real. So that's how they're going to look. So we are going to have some complex numbers. What can you do with complex numbers? Well, we can graph them on the complex plane. The way we do that is we say the x-axis is the real plane, or I'm sorry, the real axis, and the y is the imaginary. So we're going to plot these points. And people really, I know you're probably saying, if they're imaginary, Mr. Brust, who's ever going to use these? Actually, it comes up quite a bit. I'm going to try to show you some applications in here. But there are real-life applications for this. So let's talk plotting the points. It's not too bad to plot these. You know, if this is a plus bi, if I want to plot point A here, essentially you're going 4 in the real direction, 1, 2, 3, 4, and you're going up 1, 2, 3, 4, 5. There it is. That's 4 plus 5i. That is point A right there. Boom. Point A. Fantastic. Can you do point B? Sure. This is negative 2 in the real direction, 1, 2, and then negative 3, 1, 2, 3 in the imaginary direction. So that's going to give me point B over here. Cool. What about just 3i? Can I graph that point? Sure, that's the same thing as saying 0 plus 3i. It's 0 part real, all imaginary. So we can still plot that. It's all imaginary. It's going to end up on what we used to think of the y-axis, now the imaginary axis over here. Fantastic. And the last one, 4, sure, we can graph it here. It's just all real, so it's going to be on the axis, and it's got nothing imaginary about it. So really everything in the world is complex. Either it's all real, all imaginary, or it's both. Cool. Moving on from graphing. Excuse me. We're going to solve some equations with this. So how do we solve some equations? This goes back, Mr. Sullivan did some of these. You know, when you're down to nothing but the square root, what are you going to do? Well, we're going to square root, the perfect square. We're going to square root both sides. So right off the bat, I can see my problem. Ooh, bummer. That's the square root of negative 25, but this cancels the square here, so I'm left with n minus 1. Let's go ahead and break this down a little bit. What is the square root of negative 25? Well, I know it's 5 times 5, so this really becomes, again, plus or minus 5i. That I gives us that negative, and then 5 times 5 is 25. So it's plus or minus that n minus 1, but I haven't solved for n yet. What do I got to do? I got to add 1 to both sides. So really when I do this, what am I looking at? I'm looking at n equals, I've got this 1 plus or minus 5i. So if you don't like the plus or minus, you know, we're really saying it's 1 plus 5i and it's 1 minus 5i. Those are my two solutions. We're going to write it like this to save us a little time, but really you're getting two solutions. So we're getting these imaginary solutions here. In this case, it's a complex number of where it crosses. Cool. Very nice. How about the next one? A little bit trickier over here. What am I going to do? I'm going to subtract 8 from both sides. Boom. So I'm looking at x plus 3 squared equals negative 2. What am I going to do? When I've got nothing but the square root, the perfect square left, I can square root both sides. So those cancel out. I like that. So I'm left with x plus 3 equals the square root of negative 2. Let's go ahead and break down what is the square root of negative 2. It's just plus or minus I radical 2. If I times radical 2 times radical 2, I'll end up with 2. The I gets that negative part. And I've still got this x plus 3. And my goal here is to get x by itself, so what am I going to do? I'm going to subtract 3 from both sides. So these cancel out. I'm left with x equals what? Negative 3 plus or minus I radical 2. Woo, that's a lot of work right there. I like it. Again, if you want to separate it into two, you can, but hopefully you're okay with that notation. That is the two solutions. I love it. So let's bring the pain here. This is as challenging as they can get right here. I want to get y by itself. I'm going to solve for y. So what am I going to do? I'm going to subtract 7 from both sides. Boom. So it starts off just like all our other stuff we've been doing all year about solving for y. We've got minus 8 over here. How do I do this? You know, I'm going to divide by 1/3, or I'm going to what? Multiply by 3 over 1. Those cancel that out. So you multiply both sides by 3. So we've got y plus 2 squared equals negative 24. And again, now I'm ready to take the square root of both sides. So boom, I get it by itself. Take the square root of both sides. I've got y plus 2 equals the square root of negative 24. So that's pretty cool. So I've got that. Let's go ahead and break down what happens here when I square root that negative 24. I'm looking at what? Plus or minus. I don't know the square root of 24. It's not friendly, so I'm going to leave it like that. Does that break down, though? Can we break down the square root of 24? Sure. This breaks down into what? The biggest perfect square I can think of is 4 times 6. And the reason I picked 4 is why? Because I know that the square root of 4 is 2. So that's really 2i radical 6. All of that equals y plus 2. So what do I got to do both sides? I have to subtract 2 to both sides. So holy cow, all that work to come up with this final answer here as what? Y equals negative 2 plus or minus 2i radical 6. Wow, I love it. These are some crazy looking answers. They're right answers though. They're good. I think that's it. So some crazy looking answers there, but they're right answers. They're good to go. Don't forget about these imaginary guys. Don't forget about the unicorn. Good luck on the master check. I hope it goes well. Peace out.